Go first. So I want to talk to you about xDS, or blank discovery service. So what would we discover? It's about microservices. So we have a service A and a service B, and service A needs to know what the IP addresses of service B are, and for that you use discovery service. I'm Herman. I'm a software engineer at Q42. I've been in the Philips Hue team for 5 years now. This is partially inspired by that experience, and we're doing a lot of stuff in Go. So let's go to a practical example that actually happened at Philips Hue. So we have these two services. They were written in Go, and we would just have this running, but then we rolled out a new version of service B. So you get a new nice instance in Kubernetes, and then scales down the old one. So a new version, a new application, the old ones are getting a little bit busy. Does anybody see what's going on here? And then at some point, the last one has all the load, it really is on fire, everything breaks down. And yeah, the HBA even thought like the load of the system is only 25%, so let's scale it down. Yeah, that's not really helpful about Kubernetes. So what happened? Well, these two services were gRPC, and the client was connected to the server using the DNS default resolver. So if you just say service B, then it finds it using kubedns. But it depends a little bit on what kind of service you created. So normally you would create a cluster IP service, which there's a kube-proxy in between, and it basically round robins over your instances and sends the traffic to one of the instances. But with gRPC, there's one connection. So it keeps the connection open for a long period of time. So we decided to be smart and use cluster IP with cluster IP none. So that your DNS server gives back all the instances, and it can connect to every one of them. And it, you see there, this is an example, just it connects to this service. But yeah, that has a downside. If you start rolling out a new version, that something peculiar happens. And what exactly happened, I will go into next. So this is an example of the YAML file where we created the headless service. So you say cluster IP none, and then it doesn't have its own IP, because it's just returning the pointers. Well, this piece of code was nice. It is a loop in the DNS resolver where is it readable? It's a little bit small, right? Well, it's a loop, and inside it's checking every 30 seconds if it can still resolve this service. And if an error happens, it goes into a backoff. So the interval is defined as 30 seconds, but the backoff is up until 120 seconds, so 2 minutes, which is really a pain. If you're actually not resolving, and at some point it does resolve, it was backing off, so this didn't resolve quickly. We were also noticing, because we're just doing a rollout with a CFCD system, and at some point the motors were going off and the server was already down. So what do you want to do instead? So there are some internal load balancer that you can use. We want a few things, so we want fast updates from Kubernetes. So if you do a rollout, it should be pretty quick to pick up those new instances, right? It also should have low overhead. It shouldn't be interpreting requests. It should be doing little as possible, and not be a giant resource. I'm looking at Istio a little bit because it has some overhead. And it should be zone aware preferably, because ideally, if you have public clouds, so like Google or AWS, and you have those instances running over 3 zones, if you do traffic between the different zones, it adds a little bit of latency. So in the same node, or in the same node which is sitting next to this server, the latency will typically be a millisecond or less. But if you go to a different zone, it can be more like 5 milliseconds. And if you do that discontinuously, or you have a lot of interaction between your services, it adds a lot of latency if you go across zone. So preferably zone aware. So you can do a Kubernetes service, a headless one, which you just saw you shouldn't do. Not necessarily, at least be a little bit careful. You can do a cluster RP, which has the downside of, I put some processes. So it has the downside of not working as nicely for gRPC, because it just keeps the connection open. And it can also lead to imbalanced requests. And Nginx isn't that nice to configure if you are doing this dynamically. And also if you basically want to generate these kind of configurations. I've done this once, generate a huge Nginx configuration isn't that nice. There's also Envoy. Who of you knows Envoy? Can you raise your hands if you know Envoy? Cool, that's quite a crowd. But not everybody, so I will go into what it does. And you have Istio. And Istio is a service mesh. There are different service meshes. Istio is nice. It builds upon Envoy. Oh, let me move this. Do not disturb. Where is this? Monterey. I even don't know where the button is anymore. Never mind. Istio was a little bit too complex for us, so we wanted to go with Envoy, and I will explain a little bit what Envoy is. So Envoy is a proxy, just like Nginx, but it's highly configurable in a way that you can define there are a lot of options in the YAML configuration. You have a lot of plugins. You have even extensibility using WebAssembly nowadays. So you can basically write anything, it's Turing complete now. But it also has dynamic configuration using xDS. At the bottom you see a picture of the steps in the process. It's just like if you know Nginx, you can define a server block, or basically first a HTTP block, and then a server block, and then locations inside, and maybe some upstreams. These are the same concepts, but then named differently. So you have a listener, then a network filter chain, which is actually defining some routes. If you look there. And a cluster, which has some endpoints. So a cluster is not a whole Kubernetes cluster, but it's just a group of similar instances. Yeah, and you can do all kinds of stuff in those steps. So you can, in the network filter chain, you could rewrite an HTTP request to be to a different URL, or remove headers, add headers, whatever you like. You can do authentication before you send it to a backend service. But the nice thing is about these concepts, so these resources here. So let's dive into how you configure this. This is a lot of YAML, I understand, so let's zoom in. Here at the top is the listener. You define an address, a port value. This is just like you would do HTTP and then listen on port 80. Inside is the filter chain, and here for this example, a hard-coded route config, and it matches all the requests and forwards it to the same service. There is an upstream cluster, which, if you can't read this, I'm not sure, but it has a strict DNS resolving strategy and round robins over those found addresses. You see in green the address, which is a DNS address and a port. Yeah, so this is how you do it statically, but this is important to understand how you do it dynamically. So xDS again. You don't need Envoy if you use gRPC. The nice thing about well, that's actually the next slide. Let me back up. So xDS is a way to dynamically configure Envoy. You can do the sim YAML I just showed you. You can push them to Envoy instances. So if you have a whole bunch of Envoy instances and they all listen to the same configuration server, you can say, now I have an update, here's the new list of clusters. Here's the new servers I just deployed. So Envoy discovers these 4 resources, which were just shown in the YAML, using the X discovery service. So it's listener discovery service, route discovery service, cluster discovery service, endpoint discovery service, but recently also secret discovery service, and there is also some health configuration service. So there are different endpoints in this spec. And there are 4 variants. So you can retrieve all of these resources at once, or you can retrieve them per type. So you can retrieve first all the listeners, then all the, actually the routes depend on the cluster, on the listeners. So you would first retrieve the listeners, then the routes, but you could already start with retrieving the clusters and then retrieve the endpoints. But you can also retrieve them all at once. And you can also say, give me the entire thing at once, or send me incremental updates. So this is a different thing. So they're like, it's if you need the performance, so you have a large cluster with a lot of endpoints, for example, you might want to do incremental, but we don't need that in the first place. In the first case, like in a small case, we don't need that. So here you see this a configuration just like the one I showed you before, but this one defines using xDS. So you basically start Envoy with just some dynamic resources. So you say look up the LDS there, look up this in this cluster, and it knows where to find it with the address. And then the rest is filled in. Like just we saw the static configuration, you can just serve that static configuration using this XDS server. But then you will be able to change it on the fly at runtime. But you do not need Envoy because gRPC, the client, which is like the client for Go, but also for C and also for Java, they currently support the XDS resolver. So you can, instead of using some service, dial some service, you can use dial XDS resolver. And this means that it will actually make a connection with the XDS server and do the same steps as Envoy does to build up a chain, and then it knows where to send each gRPC request of yours. And you need to set this environment variable. Or gRPC is very well known for doing everything with environment variables, and there's no configuration option for this. This bootstrap JSON is very simple. You define the address of your XDS server. You say if it has any credentials. In this case it doesn't, but you can also use Google credential format, and there are some different formats. You need to give it the node an ID. That's because you might have 2 different nodes which you want to send different configurations to. And you can set some metadata for which you can use to group certain servers, so that if, for example, the name of the service A would be in the metadata, but also if you have a multi-cloud solution and you say this is the GCP service and this is an AWS service, and you just send them different config. And you can set the locality. So this is for the zone awareness. It's also just metadata. Then using this, you would just do the same as before, but with XDS. That's the, you need to import this thing. It needs to be in scope, otherwise this import picks up the gRPC bootstrap file. Registers also the resolver. And then you have this setup where your clients, your service A, are connected to the XDS server, and you can basically do anything that you want. You can respond to anything, but I specifically want to respond with something from Kubernetes. So I want to listen to Kubernetes and know which endpoints there are. If some of these endpoints are added, I want to immediately send that also to my clients. So you create a watch loop and fill the snapshot. That's basically what it does. And it's all approximately in this slide. Not really, because the make snapshot is a little bit involved. And I want to refer to my repository for that because it goes too deep to show this, how to convert this YAML syntax to some Go syntax. But you could also load the YAML syntax and then insert that into the snapshot if you want to. Yeah, so you make a loop, you watch communities, and you update the snapshot. The snapshot is also that it does the 4 variants, which I explained. So if you currently, you don't want to implement those 4 different protocols yourself, so the snapshot really helps with that. You could also do those 4 protocols yourself. That allows you to optimize a little bit more, especially if you have a lot of different nodes or a lot of different services that connect to xDS and you want to serve them something differently. Otherwise, you would be having all of the configuration of all your nodes in memory, which might be prohibitive. And I have a demo. It's also a video, but let's do the real thing. So this here is a demo client and a demo server. This is without xDS, and you're looking at K9S. So this is the tool that Christian was just talking about. Let me restart this server. There's a nice command for that. So type R, and I need to restart it, and then it scales up, and it also, the first time it didn't work, I noticed. So let's try it again. Look, now this client is down. So I just restarted the server, and the client is not ready anymore. What I did is I configured the health check of the client to do a request to the server. So if it can't reach the server, then the client goes down. But now it's not ready anymore, and this actually takes now about 30 seconds to rediscover the server. And the reason that it did work the first time was because if it loses a connection, it retries, but it won't retry faster than 30 seconds. So all the services went away. The first server went away at time 0. Then it did a rediscovery, but the new service was not there yet. So it only found the old 2, and then those 2 went away, and it had none left. And it didn't rediscover for, now they are going back. So it does take a while. And they're back up again. So it's really slow. And let me now show how this looks with xDS. Let me show this. I did some customize configuration to now switch the cluster to use some more services. And now it's starting. And this is all running on my computer. I haven't used kind before this week, so I'm not sure if I'm doing it right, but it seems to work. And it works offline, but Google Slides doesn't, so that's only the internet. Well, the headless one is not working, but that's exactly the point. So let me scale it down and be ready for the demo. So scale back to 2. And now it should just be a new instance, which should immediately connect to the server. I can even maybe scale this one to 2, like 3 or something, to make it a little bit clearer. Then, for just to be fair, I also restart all the clients now. So all the clients are gone. Get them back. All the clients are again. Once this is done. And now I will roll this thing. It carries a 4th one, and you see that now the only one that's impacted for a longer period is the headless service. So the cluster IP is also impacted, which is actually weird. I didn't expect this. But the headless service is now really down again for quite some time, but the xDS one was immediately up again. You didn't even see it go down because it wasn't. It was just between two requests of the health check that it was reconfigured. And that is xDS. Going one step further would be to use Istio. This is just for shits and giggles, just trying xDS and see if it's nice at our company. But Istio does this for you, of course. But knowing how Istio works is really nice. And there might be cases where you don't want to use Istio, but you can use this. So the repository of this presentation is at my GitHub. If you want to learn more about this example, go to snapshot.go, because there you see how the snapshot is created with the resources. There are some very nice API references for Envoy, which also explain how to create these things for xDS, of course. Istio can now also work without Envoy, which is basically using this exact same mechanism. Google Traffic Director is basically an implementation of this thing, and I had a huge inspiration or help from the guy creating the gRPC load balancer at the bottom. So shout out to him. This is some branding. If you want to work with me or with my colleagues, look us up. Figure 2, a lot of different large clients, including Philips Hue. And this is it. Any questions?
I have one. I'm assuming this is more a gRPC issue than just a normal HTTP requests thing. Is this something maybe that's going to be fixed in Kubernetes in the future?
Yeah, there's one thing which I didn't include in the slides, but I was going to write it down on my blog. The Kubernetes 1.23 or something includes a beta for the topology-aware services. And in this case, the endpoint slices contain a hint for who it is designed to be used. So you can basically filter on any endpoint slice that is destined for you. But it has a downside. It only works in particular cases if the service is well balanced, if there's no... so there are some edge cases, look them up, topology aware. And that's also a nice and hard thing about xDS. If you do this yourself and you implement zone-aware routing, then you must be aware that if you have two zones and only one of the zones has an instance, for example, then you can write from the same zone, so you don't have 0 endpoints. That's not nice. And also, if you have 1 and 4 in the other, Kubernetes is not balancing your service by definition over your zones, but you could, but it's not automatically done. And the HPA won't take into account zones as well, so yeah, beware.